All right, part 5, here we go. So final review, part 5. Maybe I should write that down first so I don't waste time. All right, so we are given some information. I want to find the equation of a sine function if my amplitude is 5 and if my period is 6 pi and if my phase shift is pi over 2 and if my vertical shift is -2. So notice that my phase shift is a positive or to the right, pi over 2, so don't forget to change that sign when we go back in. All right, so my vertical shift is a negative pi, or is a -2. So my amplitude is going to be 5. It does not say anything about a reflection across the x-axis or the y-axis, so I do not have a reflection across x. So this is not going to be negative. And then I have this sine of, now we're going to fix this in a second, but I also know it got dropped by 2. So we're going to do a little bit of work over here. First of all, I'm told that my period is 6 pi. So I do know to find the coefficient of my x in here. That's going to be 2 pi over b. So b is my coefficient. And so 6 pi is my actual period, so I'm going to cross multiply. I'm going to get 2 pi over 1, or times 1, equals 6 pi times b. So divide both sides by 6 pi, and I end up with 1/3. So my b is 1/3. So I know I can plop that in as 1/3 on x. But remember, that's on our x. So I've got x minus, what's my phase shift? My phase shift is pi over 2. Okay, so that 1/3 is the coefficient on x, but we need to reference our phase shift first, and then we're going to multiply through by 1/3 just to clean it up some. So our final answer is 5 times the sine of 1/3 x minus pi over 6 minus 2, because a third times pi over 2 is pi over 6. All right, we want to find the exact value of the following. So I'm given tangent of the arc cosine of -3/5 and then minus the arc sine of 7/25. So remember that the tangent of an angle equals a ratio, but the arc or the inverse function of a ratio will give you the angle measure. So I'm going to build 2 triangles. So we've got this one for arc cosine. Remember, it's negative. Arc cosine exists, or the domain is going to be in quadrants 1 and 2. And so for my arc cosine, I have quadrant 2 because it's negative. So this is going to be my alpha. And then I've got a -3 over 5. And when I do Pythagorean theorem, I find out that my vertical component is going to be 4. And then for beta, what I have is looking for, oops, sorry, I just drew it backwards. Looking for beta, I'm in quadrant 1 because arc sine is positive in quadrant 1. So here's my beta, and I've got a 7 over a 25, so opposite over hypotenuse, which makes this 24 when I use Pythagorean theorem. All right, so now when I step back, what I actually have is the tangent of alpha minus beta. So using your trig identities sheet, if I have the tangent of alpha minus beta, I can take the tangent of alpha minus the tangent of beta over 1 minus, or sorry, hang on, what are we doing? We're doing subtraction. Subtraction's on the bottom, so subtraction's on the bottom, addition's on the bottom. So that gives me tangent alpha minus tangent beta. Oops, tangent beta. Man, this video is a mess. All right, and then we've got 1 plus tangent alpha times tangent beta. So when I fill all this in, looking at the tangent of alpha is going to be opposite over adjacent, so negative 4/3. Minus tangent beta is going to be opposite over adjacent, which is 7/24. And then 1 plus tangent alpha is negative 4/3. Tangent beta is 7/24. So my numerator becomes, and yes, I'm going to be a lazy math person. I've got a negative 4/3 minus 7/24. Okay, find that fraction, and I get negative 13/8. So my numerator is negative 13/8 over 1 plus negative 4/3 times 7/24. And I want that in fraction form. So I get 11/18. So 11/18, and then I can flip and multiply, or I can just leave it like this. Negative 13/8 divided by 11/18 is going to give me math fraction, negative 117/44. Negative 117/44. So this is negative 117/44. All right, so for the next one, we're going to build triangles, because you're going to need this for Cal 2. Not that I'm going to sit here and talk to you the whole time, but if I am working in Cal 2, there's times that we cannot do things in algebra, so we morph it into trig. We do our operations in trig, and then we push it back into algebra. So what did she just say? I've got the cosecant of the arctangent of u, and so notice I do not have a ratio here, but yes I do, because it's u over 1. Notice as well I don't have numbers. I have variables, so I'm going to return a formula instead of an actual solid answer. So remember, I can write, I just broke my pen. I can write that as over 1. So we're going to assume that we are in quadrant 1 unless we're told otherwise. So my tangent of my angle, so the arctangent of a ratio produces the angle. So this is going to be opposite over adjacent, and I want to know what the cosecant is. Cosecant is the reciprocal of sine, so I need to know what the hypotenuse is. So using using Pythagorean theorem, I've got x squared plus y squared equals my hypotenuse squared. So 1 plus u squared is my hypotenuse squared, 1 and u. And then I'm going to take a square root of both sides. So my hypotenuse is 1 plus u squared, all under a radical. So what's the cosecant of this? The cosecant of this is going to be the reciprocal of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. So I have 1 plus u squared over u. So if I told you what u was, then you would be able to tell me what the cosecant was. All right, let's try another one. We have the cotangent of the cosecant, or the arccosecant of u. Okay, so don't just dive on over here. We were told arctangent, so this was u over 1, which is opposite over adjacent. This one is going to be the arcsecant, or arccosecant. Good heavens to Betsy. I just lost my pen. All right. So cosecant is hypotenuse over opposite. So building my triangle, we're going to do hypotenuse over opposite. And so now we got to finish out the triangle, because I need to know cotangent, which is adjacent over opposite. Okay. So I've got x squared plus y squared equals hypotenuse squared. So x squared plus 1 is u squared. I'm going to subtract 1, and then I'm going to take a square root of both sides. So this is u squared minus 1. So I have the angle that produces this ratio. What's the cotangent of that angle? The cotangent of that angle is going to be adjacent over opposite. So it is just the square root of u squared minus 1 over 1, but I'm a lazy math person, so I'm not going to write that. All right, so what do we have? We're going to do some graphing at this point. And so for graphing, I have y equals 2 times the cosine of pi over 3x plus 1/2, or sorry, plus pi over 2 plus 4. So first of all, I know that this is cosine. I know that you can slap this in your calculator, but you're going to have to tell me what the amplitude and stuff is. So my amplitude is 2. My vertical shift is 4. So we'll just say vertical shift, because it's so hard to write that word, is 4. Now I need to know what my period is, and I need to know what my phase shift is. So the period of this function is easy enough. It is pi over 3, okay, because it's your coefficient. And then my phase shift, we're going to write over here. So one of the things that you should note is, hang on, I gotta find my notes, is you had better be right. You're allowed one piece of paper. Why can't I find my notes? Give me a second to find my notes. Okay, so you're allowed to have one page of notes handwritten, and your page is 8.5 by 11 inches, and it's handwritten, it's not typed. So your phase shift is a negative c over b, so you might want to consider putting this kind of stuff in there. So your phase shift is a negative c, which is going to be a negative pi over 2 over b, which is pi over 3. And when I clean that up, I get a negative pi over 2 times 3 over pi. So that reduces, so my phase shift is a negative 3/2. And there's no reflection across x or y. Okay, so I can do this again. I have number 28 is negative half of secant. Um, 1/4 x plus 1. Okay, so remember secant does not have an amplitude. Secant, cosecant, tangent, and cotangent do not have amplitudes. But what we're going to do is swap this out for cosine, because they are reciprocals of one another. And we're going to plot cosine first. And then we're going to use the fact that we've got cosine to plot secant. And it's just going to be easier that way. So if I were plotting cosine, my amplitude would be 1/2. I would reflect across x, because it's negative, okay? My period, I don't have a phase shift, okay? So I'm not moving left or right. There's no addition or subtraction here. And so my period is going to be 2 pi over 1/4, which is going to become 8 pi. So my period is 8 pi, and then I've got a vertical shift of 1. So when you graph that, ignore this mess down here. When you graph that, you would have a damped, it's going to be a shorter amplitude. I went up 1 unit. And so instead of dropping from here at 1, I'm going to drop from here at 1/2. But then I'm going to plop it up 1 unit, which means this is 3/2, and it drops down to 1/2. And it'll look like this. And then your period is going to be longer, wider. Your period, instead of 2 pi from here to here, will be 8 pi from here to here. So why did I do all that? Because secant is going to look like this. So secant is going to be your, this is what happens when you don't draw properly, okay? So that is secant. The red stuff is secant. So plot cosine, then go secant. All right, let's try and do one more of these. So I've got sine. So I have y equals negative 1/2 sine of pi over 8x, and then plus 2. So my amplitude is 1/2. I did reflect across x. Okay, so there's my amplitude of 1/2. I did reflect across x. I do have a vertical shift of 2, positive 2. And then I would like to know what my period is. So the period of this is going to be 2 pi over 8, which turns into 2 pi over 1 times 8 over pi. So my pi is reduced, so my period is 16. Okay, and that is a great place to stop.